Example 3. Now let's talk about what we call box plots. So we're looking at a box plot. We can talk negatively skewed, symmetrical, and positively skewed a lot easier than we could with the histogram, at least in my opinion, a lot easier. So this box plot is going to show us a picture kind of like this to represent the data. And so what's going to happen if something is negatively skewed? That means you're going to have this left whisker, that's what they call this left whisker longer than the right, and also the median, that's what this line is, will be further to the right than to the left. That's if it has a tail going to the left. Conversely, if the tail went to the right, you'd see it this way where the whisker on the right is longer. This would be positively skewed. The median would be to the left, but there's a lot more values that extend out further this way than they would over here. And now symmetrical would be if everything looked pretty well the same. So on our data, for real quick, I'll give you a new example, but I'll just show you on this one. If I had switched from a histogram, let me take off histogram and open up box plot, you can see that this one was left skewed. See how that whisker is longer to the left than it was to the right? That would be left skewed or negatively skewed. Now let me put them one on top of the other, and you can see how this data, I think it's kind of, you can see that it does seem to be left skewed, but it's easier to tell on the box plot that it's left skewed, that the whisker is longer on the left side than the right. Okay, so now let's go to a new example. It says home sales. The table shows the prices of homes recently sold by a realtor. Construct a box plot and use it to describe the shape of the distribution. So let's go up to our data set, and this time we have new values. So we have 95, 110, 115, 150, 152, 154, 156, 165, 165, 168, 168, 170, 175, 177, 184. Okay, if I got this data in correctly, when I come down here, I'm going to hit the little zoom fit. And let me try that again. Zoom fit. There we go. And we see this data. Now, right now, there's not a whisker going out. This whisker is in here. That's because these values are what we call outliers here. They're outliers. But you can still see this is negatively skewed. Why? Because the median is not in the middle of this would be the interquartile range here. The median is shifted to the right, so this is still left skewed. Let me take a picture of this here. Give me a moment. Okay, now there's the data. So this would still be left skewed or negatively. Let me just say negative or left skewed. In which you could say skewed left if you wanted to as well. A little dyslexic there. There we go. This is negative or left skewed. Here's the median. Median is to the right. So since the median is right of the half, that means it extends out later to the left, so that all this would kind of represent the tail, if you will. The tail, how we kind of thought of it before, that side over here. So you see how this would have a longer tail. These are actually called outliers. Each one of these three things would be outliers, and this is called a whisker. Just so you have an idea what everything refers to. This would be the interquartile range in here. Interquartile range. And you can get the values. This would be from like 150 to 170, the interquartile range, and the median would be right there at 165. Okay, so part B. Now that we have that table, and I'm actually going to copy this one more time so we can look at part B. It says the table shows these same instructions. Table shows the prices of homes recently sold by realtors. Summarize the center and spread of the data using either the mean and standard deviation or the 5-number summary. Justify your choice. Well, I'm going to go ahead and list off all of the values again. So the mean, let me scroll down so we can see them all, is 153.6. I'm not rounding, so I just use the equal sign. The standard deviation, sigma, is approximately 26.3. Now, I would not use this value, though, these two values, because it's not symmetrical. So what I would use, though, is the five number summary, that the minimum is 95. Quartile 1, the first 25% of values fall 150 or less. The median value is 165. Quartile 3 is the top or the lowest 75% fall within 170 or lower, and the maximum is 184. Now this is what I would use. So the range of values are from 95 to 184, and the inner quartile is 150 to 170. So I want you to see here, this is the mean, not the median, not the mean, but the median, and that's at 165. This is quartile 1, and you can see if you pull that down, that value would be 150. This is quartile 3, and you can see that that value is 170. The minimum value is 95. You can see that right there is 95. And this is the maximum value here, which it looks like it's 185 to me. 185. So that's how you can get all these values there. 185. You can see where those are found. Oh, it's actually 184, not 185. Looks like that must be just inside that line there. Yeah, it's hard to see. Let me show you on this one. If I zoom this in, it's not quite at, let me get 185 listed. There's 185. You can see it's not quite to 185. All right. Now I have one for you to try. I'll let you read this. Pause the video if you need to enter in your data. And now here are your whisker plots to look at. Your box plots, rather. Pause the video if you need to.